stars that are about 10 times or 20 times as massive as our sun, when they run out of fuel and all the nuclear fusion has stopped, the inner parts of those stars collapse into something we call a neutron star.
It compresses down to something about the size of a city, and the pressure and density are so high that every atom inside what used to be the core of the star disintegrates into the constituent protons, neutrons, and electrons. The protons and electrons combine to make neutrons, and the whole star, more or less, is composed of ultra-dense neutrons.
They're so dense that they contain a mass around the mass of the sun, but crammed into a volume around the size of the city of Chicago, making them some of the densest objects in the universe. And we just detected two of these very, very dense stars spiraling around one another.
But doing that, they lose energy, because Einstein predicted that they are losing energy through gravitational waves. So they lose energy, which means that they are not able to support this movement anymore, and then they get closer and closer and closer, and boom.
We have about 100 seconds of this in-spiral signal that we can analyze very carefully. And at the end of those about 100 seconds, we see a burst of radiation right when the two neutron stars collide at the end of the death spiral.
It's just like having two cars that they crash. So this very same thing also produces light. You warm up a lot this material, you produce light.
So that's what we observed. For the first time, we saw the final collision of two neutron stars. And for the first time, we saw this multi-messenger message of combined gravitational waves and electromagnetic waves.